What you see on the screen now is an example of a congested corridor, much like the San Mateo 101 corridor. The top lane, which is currently a carpool lane, is filled with carpools and buses. The green vehicles represent buses. The purple vehicles with dashed borders represent cars with 2 people and clean air vehicles. The blue vehicles with solid borders represent cars with 3 or more people in them. And finally, the yellow vehicles with no border represent cars with only 1 person. This example is meant to show the mix of vehicles that were observed on the San Mateo 101 corridor before COVID-19. This shows that if we were to implement a standard HOV 2+ carpool lane, in which vehicles with 2 or more people can use it for free, it would be congested with the high occupancy vehicles already present in the corridor. This group of high occupancy vehicles include 2-person carpools, buses, and clean air vehicles, which can drive in the carpool lane, even if they only have a single person. If this was the solution we chose, it's possible the speed of travel in the carpool lane would sometimes be slower than in the general purpose lanes, as illustrated here by the speeds on the left-hand side of the graph. The result of this is a carpool lane that wouldn't perform any better than a general purpose lane or the general purpose lanes next to it. A carpool lane is traveling at the same or slower speed than the general purpose lanes and does not provide an incentive or benefit for people to use a carpool. Now, let's take a look at a second approach to addressing congestion in the corridor. If we were instead to consider a carpool lane in which 3 or more people could use it for free, as compared to a carpool lane for 2 or more people, we would see a lot of space in the carpool lane, as shown here on the top lane, because that lane would not allow single occupant or 2 occupant vehicles to use it. Since there would be less cars in a carpool lane of this type, the speed in the carpool lane would be much faster than in the general purpose lanes. But the carpool lane would be too empty, and the general purpose lanes would travel slower than if we were to implement a carpool lane requiring cars with at least 2 people. The reason for this is that the 2-person vehicles are now in the general purpose lanes, creating additional traffic congestion and slower speeds, as illustrated at the left-hand side of the graph. This approach takes away too many vehicles from the carpool lane and makes travel in the general purpose lanes slower. This creates a disadvantage for cars in the general purpose lanes. So what then is the third approach? The third approach is to implement an express lane that fills the empty space in the lane just enough to provide a benefit to carpools as well as vehicles in the general purpose lanes. The express lane allows solo drivers the option to pay to use the carpool lane for vehicles with 3 or more people, while maintaining speeds of 45 miles an hour or higher. This increases the speeds in the general purpose lanes because we've moved some of the cars out of those lanes and into the express lane. As you can see, the express lanes would operate at 45 miles an hour, while the speeds in the general purpose lane would be 5 to 10 miles per hour higher than in either of the other 2 examples. With an express lane, high occupancy vehicles travel faster than the general purpose lane traffic, which saves time. This provides an incentive for drivers of single occupant vehicles to switch to a carpool or bus, an outcome that improves the travel and improves air quality. This is why the San Mateo County leaders decided an express lane was the right way to address traffic congestion on US 101.